there's a supercluster, sixth largest object known at 1 billion light years. 1 billion light years, more than 1% of the entire size of the universe. And even this right here, this thing, which contains 1 billion light years across worth of stuff, is about 1% of the observable universe. Hello. If you've ever even been slightly curious about the universe and all of the big and all of the small that it has to offer, you might have found yourself on a website such as this, where they give you the opportunity to zoom in and zoom out to bear witness to everything that you don't necessarily see every day. Now, I've recently seen the movie Oppenheimer. If you haven't seen it yet, and you've got 3+ hours to kill, I highly recommend it if you're interested in science, and just the universe, just the craziness of it all. It's a beautiful film, very fast-paced, even though it's 3 hours long, but it kind of sparked my curiosity once again to dive into this type of, I don't know if I would call this research, but just a way to scratch that itch. So on this particular website, we're going to start at human size, and as you can see, we have a scale down here. I want to say the entire gray bar represents 10 meters, which is about 30 feet, and all of the objects that we continue to zoom in or zoom out on will be represented on this scale, although this will not say 10 meters for long. It will change based on the direction we go. On this particular website, when you click on something, you get to learn a bit about it. Now, I don't really need to learn about a beach ball, but it might be interesting to click on some of these as we go, especially when we get to the really, really tiny and the insanely large. So I think we should get started here. Starting with, let's just start with the human. And we know what a human is, but it's a nice starting point. So human, 1.7 meters. I'm going to assume you are human. I am a human too. Did you know that there are almost 8 billion of us? That's a lot. In fact, if you met each person for 1 second, it would take you about 200 years to meet all of them. Better get started now. Okay, let's continue to move in. Something similar in size to us would be the dodo bird. Obviously, they're a bit taller, or smaller rather. About a meter. The dodo bird went extinct sometime during the 1600s. The name comes from the sound they make, or should I say used to make, since they're now extinct. So yeah, they're gone. The dodo bird. They're close to bringing these back through bioengineering, which is fascinating. The mammoth, the dodo bird, the Tasmanian tiger, and they've they've even brainstormed whether or not they should bring back the Neanderthals, which is definitely highly controversial. But technically doable. Technically. Okay, as we zoom in, we begin to notice some smaller objects. Of course, we have a ruler, we have a basketball, we have a shrew. Let's see what they say about the ruler. 30 centimeters. For all of you people not accustomed to the metric system, here's an inch ruler, which is approximately 1 foot long. Unfortunately, almost everything else is in the metric system. Yeah, in the United States, and I think in one or two other places, we are holdouts on the imperial system. The largest hailstone was 20 centimeters. The largest hailstone was found in South Dakota. However, most hailstones don't even come close to this size. The average diameter is a measly centimeter. Oh, I would also like to point out that not all hailstones are round. Yeah, I don't live anywhere where you'd have to worry about insanely large hail. I can't imagine what kind of car insurance you would need for a place like that. Okay, we keep zooming in. We're officially down to a square inch. Microwave length. Interesting. So about 2 wavelengths. I don't know if you'd consider this 2 or if you'd consider it 1, 2, 3, 4, 5 wavelengths. But about 2 up down. Microwave pennies or microwave waves are about the size of a penny. Let's go ahead and see. Microwave length 1 centimeter. Actually, the range of microwaves is pretty large. They range from 1 millimeter to 1 meter. So you see, this electromagnetic wave with a wavelength of 1 centimeter comfortably fits into the range and thus is a microwave. Microwaves, from what I understand, are relatively harmless. They're not intense enough to do us any damage. Okay, now we're starting to get into the microbiology. We've got bacteria here. It's crazy to think that there is some bacteria that's larger than an ant, but we are 10 to the negative 2.1 meters, so we're getting smaller. Let's see what the largest bacteria is. 9 millimeters, so visible to the human eye. The largest bacteria, which is Theomargarita magnifica, is almost 1 centimeter in length. It was discovered in the swamps of Guadalupe. Can you imagine being in the water and seeing these things? They're very visible. I would love to look that up because I'm quite interested in that. Theomargarita magnifica. It's an interesting name. Okay, we've got pencil lead of all 3 typical sizes. I prefer 0.9 lead. I used to love 0.5, but I don't know. I can't stand it now. It just squeaks every time you write with it. People use pencil lead a lot. Oh, by the way, this is mechanical pencil lead. On another note, the largest pencil contains 2,000 kilograms of graphite. That's about 3 times heavier than a human. And by a human, I mean the heaviest human ever. 700 micrometers for a pencil lead. So micrometers, even smaller than millimeters. We've got a grain of rice. Duckweed. What exactly is duckweed? These are water lentils that float in ponds and other bodies of water. They don't have stems or roots. On the other hand, they do create flowers, which are the smallest of any plant on Earth. 2 millimeters. That's insanely small. But we're not even close yet, as you can see on our scale down here. We keep going. Width of a human hair. A pixel on a phone or television. Let's see. see what else we've got here. The thickness of a piece of paper. A grain of salt. This is where it gets interesting. Okay, a dust mite. 300 micrometers. Dust mites like to eat dust, which you probably know is just dead skin cells. Many people are allergic to dust mites. Some people are allergic to their poop. Either way, almost all people want to get rid of this something. I can't see it behind the... Oh, this pesky pest. Okay. What about an amoeba? 350 micrometers. Amoeba are unicellular, which means there is only one cell. Some amoeba can grow to an incredible 700 micrometers, which is almost an entire millimeter. So this is roughly a third of a millimeter, so technically still visible, but this is a single-celled organism, so this particular cell contains the DNA and all of the organelles of this organism without needing multiple cells. It's just one cell. I would assume, I'm not sure if it's prokaryote or a prokaryotic cell or eukaryotic cell. Prokaryotes don't have a nucleus in their cells, but a eukaryote does. I'm not sure what an amoeba would be. I don't know. Speaking of cells, we're getting a bit smaller. The human egg cell. An ovum is the largest cell in the human body. Animals that develop within eggs within their mothers are ovoviviparous. Ovoviviparous. That's a crazy word, which humans are not. Ovoviviparous is the only English word starting with vowel V, vowel V, vowel V, vowel. Yeah. So human eggs are and this is the largest cell. It's about 1/10 of a millimeter in width. Parameciums. These little guys are protists and like to swim in water. They can move 2 millimeters per second. I've seen these under a microscope before. Parameciums that belong to protistas. If I'm saying that right. Mist droplet. Skin cell. So this purple piece is a nucleus, and we humans are eukaryotes. So our cells are eukaryotic cells. Therefore, we have nuclei inside of our cells that contain DNA. 35 micrometers. The outermost layer of skin, which is also the only visible layer of skin, is made up of dead cells. That's because dead cells are the strongest, and stronger skin provides more protection. These cells continuously fall off. In fact, dust is 95% dead skin cells. I don't know how true that is, but if true, that's flippin' gross. But kind of expected. Are these distances? Let's see. So we're getting into cellular anatomy here, I'm noticing. What's this? Although the word thou is most commonly known as being an old form of the word you, a thou is also a unit of measurement. It is equal to 1/1000th of an inch. In fact, that's where it gets its name, thousandths. Pretty cool. So if a thou is 1/1000th, what's a twip? A twip is the 20th of a typographical point. That means that 12-point font is approximately 240 twips high. Also, DUIP can stand for the universe in perspective, an old name for the scale of the universe. DUIP and TWIP are pronounced the same. That's weird. Okay, so skin cells are relatively large, but as we continue to zoom in on the human body, you've got your white blood cells that fight disease. This is the nucleus of a cell, which contains your chromosomes and your DNA. Nuclei are pretty cool, and they can be found within all eukaryotic cells. Human cells are eukaryotic. The nucleus is where all the DNA is. During mitosis, the DNA will condense into chromosomes, and then the cell will split in two. And that's how we do all of our division, and it's how we develop new cells. your DNA condenses into these rods, and these split right down the middle during mitosis, which is the process of cell division. And so each cell will get half of each chromosome, which allows them to have identical DNA because everything is copied before mitosis begins. Let's see what they have to say about the different chromosomes. X chromosomes are absolutely wonderful. Most chromosomes look like X's even if they aren't sex chromosomes. Those are autosomes. In humans, females have 2 X chromosomes while males have an X and a Y chromosome. Some people might have 3, 4, even 5 chromosomes though. Okay, and then the Y chromosome, a sex chromosome, appears only in males. Did you know that the Y chromosome is continuing to shrink as it evolves and might possibly disappear completely? I find that to be very fascinating. Some animals, like the amami, what do? Amami spiny rat have already lost their Y chromosome. Interesting. Alright, we're into some more condensed wavelengths. We've got red light wavelength. Red is the first color of the rainbow and the longest wavelength of light we humans can see. It stimulates appetite. That's why so many food companies have red in their logo. They want you to eat. In short, they're trying to fool your brain. Thanks. Okay, violet light. So is this the smallest wavelength? I cannot remember. I think it is. Here's the largest virus. Known as pythovirus, was discovered 30 meters underground in the Siberian permafrost. It's thought to have been there for 300,000 years and still able to infect living things. Thankfully, it seems to only be interested in amoeba. Interesting. So we're getting into some viruses. And yeah, viruses look very, very weird. And of course, this is just an illustration of one, but they're very odd-looking things. The bacteriophage, or just phage, is for short, is a type of bacteria infecting virus. I think they look like robots, not life forms, but it also could be argued that viruses are not alive at all. That is a common argument. They require a host to actually really be alive to carry out their functions of life, so there's an argument to be made about their true sentience, or maybe sentience isn't the right word, but their true organic nature. Virus, ultraviolet waves. This is where we're getting dangerous. This stuff can destroy skin cells. It can give you a tan. I used to think the sunlight and heat burned your skin to make it darker, like how a barbecue grill turns all the food black. Now I know that's not true. Yeah, I don't know the exact science behind tanning, but I'm sure it has to do with just manipulating the pigments in your skin. Smallest thing visible to an optical microscope. They cannot see objects smaller than 200 nanometers because the wavelengths of visible light will pass right through them. That's interesting. So you need to switch over to an electron microscope at that point. The HIV virus, hepatitis virus, DNA. So viruses basically infect your cells and mess up your DNA. That's the very, very, very simple way of putting it. So let's take a look at DNA. DNA, which is a nucleic acid, stores the genetic information of almost all living things on Earth, except for some viruses. A single human cell contains 3 meters of deoxyribonucleic acid, which holds about 25,000 genes and about 3 billion base pairs. Yeah, there's a reason we're all different. So the base pairs, you're talking adenine, thymine, guanine, and cytosine. Adenine only ever pairs with thymine, and guanine only ever pairs with cytosine. And That's what these colors represent on the DNA strand. The different bases, nitrogen bases that compare. But different combinations allow for different manifestations of certain genes. And you get enough of those combinations together and you end up with a person who's unique and all their own. It's pretty insane stuff. Okay, let's keep going. We're getting there. We're down to 10 to the negative 7.4 meters. Porcine circovirus. A transistor gate. That's interesting. Transistor and computers are continuing to get smaller. In 1971, they were 400 times larger at 10 micrometers. Now we are down to 5 nanometers. But in the future, they might even be smaller. How small will they get? Moore's law predicts we can make new transistors half as big as before every 2 years. So we have transistors that are as small as DNA. That seems insane to me. That's ridiculously insane. Okay. Phospholipid bilayer. Before I click on this, I believe they're referring to like a cell membrane around a cell. Phospholipid bilayer. It's what allows certain nutrients to get in and out of the cell. Yep, there it is. Cell membranes are made of phospholipid bilayers. Phospholipid bilayers can form naturally because the heads attract to water and the tails repel from water. As a result, tails clump together, forming the bilayer. So basically, and I could be wrong about this, so if you know more than me, please let me know, but basically these heads attract water. So water wants to come towards the layer, but once it's past the head, it's stuck in this middle, and these tails retract water. Was that the word they used? Repel. That's the word. They repel water. So what it does is it shoots them through to get away from that as fast as possible, and then this head will grab it and allow it to travel through. Water can get in and out of the cell via osmosis relatively easily there. Alpha helix. So this looks like part of the DNA strand. Let's see. The alpha helix is one of the secondary structures of proteins. Oh, interesting. Many proteins have alpha helixes within them. Helices within them. Hemoglobin and myoglobin are proteins that are made of about 70% alpha helices. I need to know more about that to comment. There's a singular phospholipid molecule. Buckyball. We are getting very, very tiny here, but we're not even close to the tiniest. Buckyballs, which are also called Buckminster fullerenes, are made of 60 carbon atoms. The shape is formed in a truncated icosahedron, which is also the shape of a soccer ball. A solution made completely out of buckyballs is violet. Okay, glucose. No comment on buckyball, but I like it. X-rays. Interesting X-rays. Pretty tiny glucose molecules. Carbon nanotube. Strongest material yet discovered. It looks strong. As another bonus, they're lightweight, 1 nanometer. As a result, nanotubes have a lot of potential applications, including buildings, batteries, solar panels, and possibly even space elevator. I don't know how you work with something on such a microscopic level. Okay, now we're getting into the atomic level. We're passing microbiology, going straight into atomic science, I guess. So, without getting into it too much, obviously we've got some atoms here, and I'm just going to keep going until I get to that. Oh, here's a molecule. So this atom is larger than this molecule. Let's see what it has to say. 280 picometers. I like to think that whenever I drink water, I drink Mickey Mouse heads. Do you too? Oh, you don't? Well, you should. Yeah, I see Mickey Mouse every time I look at a water molecule as well. So let's look at the carbon atom. So when you look at an atom in the center, you're going to have a combination of neutrons and protons. It's not showing any neutrons and protons. It's just showing a red circle, but because carbon's atomic number is 6, you would assume that you would see, I believe this is accurate, you should see 6 neutrons, 6 protons in the middle. Now neutrons are neutral, protons are positively charged, and these yellow ones are electrons, which kind of glide around the outside, and electrons are negatively charged. So if you have 6 positively charged protons, you need 6 negatively charged electrons to have a stable atom. And carbon has what looks to be called, these are called valence electrons. If they're on the outside shell, there's multiple shells to an atom. And valence electrons are used in combining with other atoms to create molecules, I think. I'm pretty rusty on that stuff. Carbon is the basis of all life on Earth. This is because carbon atoms can create 4 covalent bonds, which means it can bond in thousands of ways with oxygen, nitrogen, carbon, and other elements. So I wonder if the covalent bonds come from the valence electrons. Okay, hydrogen atom, smallest thing visible to an electron microscope. Interesting. I wonder how we're seeing things smaller than that, unless it's all theoretical at a point. Electron microscopes allow us to see very small things like atoms that would otherwise be invisible because they are smaller than the wavelength of visible light. Angstrom. An angstrom, 100 picometers, which is named after Swedish physicist Anders Jonas Angstrom, is 1/10 of a nanometer. The symbol for an angstrom is A with a circle on top. The angstrom is used to express the size of atoms or transistors. Okay, let's keep going here. We're getting past the atoms. There's gamma ray, which is why it's so dangerous. It can easily penetrate you on the atomic level. Gamma rays have a very high frequency. They can come from radioactive decay. Oh, and by the way, it's not actually light blue as it appears to the left. Okay, so keep in mind, gamma rays are insanely tiny compared to everything we've been looking at, but look how far we have to scroll to get to the next smallest thing. Now we're talking the nucleus of particular atoms, not a cell nucleus. A cell nucleus has DNA and various other components within it. Now we're getting into the atoms. And one cell could be, gosh, I don't know the numbers, but you're talking probably millions, if not billions, of atoms. I hope that's accurate. And then one atom, each atom has their own nucleus. And again, you should see the equal number of reds and grays, because you should be having, like helium, its atomic number is 2, so 2 protons, 2 neutrons, and then it should have 2 electrons swirling around it. Speaking of electrons are so small that their size can't accurately be measured. The size of an electron varies greatly depending on how it's measured, whether it's based on the quantum model or, in this case, the classical model. I am unfamiliar with that. There's a neutron and a proton. 1 femtometer. Neutrons are found within an atom's nucleus. They are thousands of times smaller than the atom itself. They have 2 down quarks and 1 up quark. Therefore, the neutron charge is negative 1/3 minus 1/3 plus 2/3 equals 0. Okay, sure. So lengths shorter than this are not confirmed. All the objects that are smaller than this are unmeasured. The sizes that they appear are only estimates. Some things like quantum foam are just hypothesized. They aren't fact. So what we're getting into now is quantum mechanics and quantum theory. And this is where things get probably pretty trippy. Range of the weak force. The weak force is one of the 4 fundamental forces of nature, and is the weaker of the 2 nuclear forces. As distance increases, its strength decreases. At just 10 atometers, the weak force is so weak, it is unmeasurable. Okay, there it is. Those are the quarks and the neutrinos. This is where my knowledge ends. I know nothing about this stuff. High energy neutrino, 15 centimeters. Again, just an estimate. Neutrinos of higher energy are larger. For more about neutrinos, go to neutrino, which shows the average size. It's a whopping 15,000 times smaller, so we'll get to that one eventually. There's an up quark and a down quark and a strange quark. They're all strange. 10 centimeters. There are 6 flavors of quarks. They are up, down, strange, charm, top, and bottom. The smaller a quark is, the more mass it has. As a result, the up and down quarks are actually the lightest of the quarks. Okay, so the smaller it is, the more mass it has. That's interesting. So strange quarks, charm quarks, bottom quarks. The bottom quark is also called the beauty quark because it is so flawlessly beautiful. It is third generation and quickly decays into up and charm quarks. This doesn't make any sense to me. If you study quantum physics or quantum theory, I'm sure this makes a bit more sense to you. 10 to the negative 22, way down there. Okay, there's neutrino. Neutrinos pass through ordinary matter like you and me all the time. In fact, they're doing it right now. Neutrinos have no charge, so they are only affected by gravity and the weak force. However, they are so small that they are barely affected. What about by the strong force? The top quark is the smallest quark, which means it is the most massive. It is almost 100,000 times as massive as the up quark, which is the lightest of the quarks. The top quark's mass is 173 billion electron volts. I guess that's a lot. Let's go see what an electron volt is. Way down. I'm scrolling and scrolling and scrolling. That's what I thought we'd run into. Are we getting into string? Yep, there it is. At the very fabric of the universe, it has been theorized that there is something called quantum foam. What exactly is it? Yeah, it's very tiny. According to the space-time theory, again, we're just dealing in quantum theory here. Quantum foam, which is also known as space-time foam, is the foundation of the fabric of the universe. It is impossible to directly observe or measure this because it is so small. So if the universe was a blanket, this is the stitching, is essentially what it's saying. And anything that exists in the universe leaves an impression on quantum foam such as this, which that impression is gravity, from what I understand. So something like a human is not going to leave a very large impression, but something like a planet leaves a very deep impression in the quantum foam, which forces things to revolve around it and be pulled towards it. That's my ignorant description of that. But even below that, there's the Planck's and the strings, and I've heard of these, I just don't know much about them. The Planck length is a unit of length. There is also a Planck time, which is the amount of time it takes light to travel 1 Planck length in a vacuum. So basically nothing. So this is a unit of measurement. According to string theory, strings are one-dimensional but vibrate in all the other dimensions. This string, however, is not the same string that is used for flying kites. That string is between 10 to 32 and 10 to 33 times larger. It doesn't say much about string. I don't know much from that description. But that is the very fabric of the universe. We have gone as small as possible, as far as we know. But we're just scratching the surface. It's time to go in the opposite direction. Just keep going and going and going and going and getting larger. Neutrinos, they look so large, don't they? Wow, these are such massive pieces. Keep it going, keep it going. We've got the weak force. We've got the neutrino. neutrons and the protons and the atoms, nuclei, gamma rays, and full atoms of different types. We've got the phospholipids and the transistors and the bilayers, up to DNA. DNA is large. Holy cow. Bacteriophage, the viruses and the chromosomes and the cells. We're now into microbiology and the cellular level. We've got creatures, multicellular creatures like the dust mite and the ant and the bacteria, the penny and the common earthworm and the shrew and the dodo bird and the human. Now, let's travel in the opposite direction. And this time, let's go out into space and see what awaits us. This is a beautiful dinosaur. I have to click on it. The Tyrannosaurus Rex. This dinosaur is now extinct, but it used to be up to 7 meters long. Although the T-Rex was very large, it was not the largest. Zoom out a bit to see the largest dinosaur. I would assume the largest dinosaur is going to, of course, go to like Brachiosaurus or Titanosaurus or something like that. A four-legged, what do they call them? Something pods, I forget. The four-legged, larger ones. There it is. The Marapunisaurus fragilimus was the largest dinosaur ever. It weighed over 100 tons. It's so big you could build your house on top of it if you wanted to. The Apollo lunar module, average house in the United States, the blue whale, which is the largest animal on Earth today. We've got, or maybe ever, I don't know, Statue of Liberty, the Titanic, the Gateway Arch, Boeing 747, the International Space Station, a redwood tree. The Titanic was 270 meters. The Titanic sank when it hit an iceberg. Although it was capable of holding enough lifeboats for 4,000 people, they decided they only needed enough lifeboats for 1,178 people. There were 2,228 people on the Titanic. Dang. Hoover Dam, the Half Dome, the Great Pyramids of Giza, AM radio wavelength, much larger. A and M are the first and 13th letters of the alphabet. 1 is a perfect square, while 13 is not. We all have our differences, and we have to learn to accept them. That's the only way we'll live in harmony. Okay. Angel Falls, Boeing Everett Factory. Crethine. Is this a moon or asteroid? Crethine is known as Earth's second moon. I'm saying the name wrong. I'm sorry. It actually isn't Earth's moon. It just follows an elliptical orbit around the sun that is near Earth's orbit, and its year is 364 days, close to Earth's year. Interesting, I did not know that. Phobos and Deimos. Are these Mars moons, I believe? If so, they're very tiny. If that's a waterfall here on Earth, what's the Palm Jebel Ali? Palm Jebel Ali is the largest man-made island, not including islands like Flevopolder, where a region of the Netherlands was drained. Okay. So Deimos, Mars is, let's see, smallest known moon in the solar system for almost 100 years. You could walk around it in a day. Of course, you'd have to wear a spacesuit to survive in the vacuum of space. I don't think you could walk as fast in a spacesuit, though. It doesn't tell me what planet these are for. Okay, it's the larger of the two Martian moons. I think both of those are Martian moons. If you were standing on Phobos, its gravity would be so weak that you could throw a baseball and it wouldn't come back down. Awesome. We've got Halley's Comet. I was hoping it would say when we would see it next. The length of an average marathon. Rhode Island, a neutron star. They're made of tightly packed neutrons. As a result, they are extremely dense. 1 milliliter of neutron star material weighs 1 billion kilograms. It's just ridiculous. West Virginia, Rwanda, Brunei, California, Grand Canyon, Hydra, Italy. Okay, we're getting into some of the actual larger moons of our solar system, and then we've got poor Pluto here. I prescribe to the truth, and that truth is that Pluto is still a planet, goddammit. Pluto is no longer a planet. Yes, it is. Why do people feel sympathy for it? It has no feelings. Even if it did, why would you care about what people way over on Earth thought? Why would it care? On another note, Pluto's official name is now 134340 Pluto because it's a dwarf planet. Yeah. I still like to think of it as a planet, just cause we've got Earth, we've got Venus. I want to say Venus is considered our sister planet. Let's see what they say about Mars. Mars is known as the red planet. It is red because it is rusty. Many people believe water and life once existed on Mars. However, even if that is true, the life wouldn't be like the little green men on sci-fi stories. Yeah, the idea of aliens doesn't necessarily mean little green, skinny, big-headed dudes. They could very much just be bacteria, which isn't as fun, I guess. So 12 megameters. There was a time when Venus and Earth were thought to be sister planets. There it is. There's that term. That isn't true at all. Dang. Venus's surface temperature is always above 450 degrees Celsius because its atmosphere, which is mostly carbon dioxide, traps the sun's heat. Yeah, it's insanely hot there. We've landed a craft there. It's fascinating to see the footage. It's seconds of footage before it breaks apart and basically dies. But just the idea that the fact that we have footage from these other planets, it's just so fascinating. Alright, what do they say about Earth? The Earth is our only home. While living on it, we may consider it huge, but it is still important to take care of it. When it's gone, there will be nowhere else left to go. We think it's huge, but let's zoom out and decide just how huge Earth actually is. The Minecraft world is larger than Earth. Stretching from the coordinates 32 million to negative 32 million, the Minecraft world spans a total of 64,000 kilometers. This world has approximately 130 quadrillion blocks in it. That sure is a lot. And here we go. We're leaving our solar system. Well, I'm sure Jupiter is right around the corner. Yeah, Jupiter and Saturn. But now we're getting into some relatively small suns. What is the distance from Earth to the Moon? 380 megameters. The Earth and the Moon here are not to scale. If the distance were a meter, Earth would be the size of a quarter, and the Moon would be a pea. Yeah, it's hard to draw to scale on something on such a large scale. Alpha Centauri b, I believe this is the closest other star to us. It's the second largest star in the Alpha Centauri star system. Its diameter is approximately 1.25 million kilometers, so it is slightly smaller than the Sun. Alpha Centauri A and B are so close they appear as a single star to us Earthlings. I could be wrong about them being the closest star to us. Let's see. There it is. Alpha Centauri A is the largest star of the Alpha Centauri star system, composed of 3 stars, which is the closest star system to us. It is also the 4th brightest star in the night sky. Closest, but not the brightest. There we go, some larger stars. So there's our sun. Our sun is massive. It just is. Also known as Sol, the sun is what gives Earth the energy that makes it able to have life. It's over 100 times larger in diameter than Earth. 20,000 times more solar energy hits the Earth than the human race uses. Now, if we think the sun is large, just we wait. We're only at 10 to the 9.8 meters. Total human height. Oh, is that if you stack every human? That's weird. If all of the 7.8 billion humans stood on top of one another and the bottom 7.7 million humans didn't crumble under all the weight, the stack would be approximately 13 million kilometers tall. Okay, well there's our sun. Just keep that in mind. That is a pipsqueak compared to some of the other stars out there. Let's take our pick. Let's read about Aldebaran. Aldebaran is not to be confused with Alderaan, which is a planet in Star Wars. Alderaan is very similar to Earth in size, day length, and water cover. However, Aldebaran is 4,900 times larger, rotates every 520 Earth days, and has no water. Is it a planet then? The way they just talked about it, it's like they're comparing it to Earth. Interesting. Okay. Distance from Earth to the Sun. So even these massive ones, remember the Sun is way down there, that little dot. I believe that was the Sun. Yep, that's the Sun right there. Look at it disappear. It's just a little pixel on my computer screen now compared to these ones. And even these are pixels compared to these stars. These stars, I mean, come on. Are you kidding me? These are insane. I know you're thinking, whoa, that's a big star. That's exactly what I'm thinking. Well, I guess you're right, because it's one of the biggest known stars. WOG G64 is found in the large Magellanic Cloud. There is a cloud surrounding the star that extends half of a light year. So, a light year is the distance. It's not a time measurement, really. It's a distance. Half of a light year is the distance that light can travel in half of a year. So, it's saying here that there's a cloud surrounding the star that would take light half of a year to travel across. That's just ridiculous. Distance from Neptune to the Sun. This star almost encapsulates the distance from Neptune to the Sun. Almost all of the interior solar system and reaching out into the outermost part. The Kuiper Belt, I believe this is our solar system. This is the asteroid belt around our solar system. Kuiper Belt is a region of the solar system outside of the orbit of Neptune where small bodies orbit. Many dwarf planets exist here. It's like a larger asteroid belt. Yeah, we have a smaller asteroid belt between Jupiter and Mars, but the Kuiper Belt, kind of a shell around our entire solar system. The Voyager 1, we sent this from Earth in, I believe, the 70s, and it's been traveling into deep space ever since, so that's how far it's gotten in 50 years, right there. Over the last 45 years, Voyager 1 has traveled to a distance of 23 billion kilometers, which is the furthest any man-made object has gone, and every day it gets 1.5 million kilometers further away. You can see it even if you can't see it, even if you stare really, really hard. So it's traveling 1.5 million kilometers a day. That's insane. And it's just out there in space. I don't know if we're still receiving any sort of transmissions. So this is a light day, so the cloud around that star must just extend insanely far. But a light day, even in just 24 hours, light manages to zoom across the distance of 26 billion kilometers. Yeah, we got nothing on light. Distance from comet Hale-Bopp to Sun. Interesting. When it's at its furthest. Distance from Sedna to the Sun. What's Sedna? It is very far away. This point is called aphelion. It takes in over 2,000 Earth years to complete one orbit. I wonder if Sedna was down there somewhere. Okay. Once you leave the solar system and the surrounding area, you start getting into the nebulas. Nebulae? Not sure. So, the Stingray Nebula is a planetary nebula. It is relatively young and is constantly growing. Whoever named this nebula must have thought it looked like a stingray. Do you? A little bit. I can see it. There's the distance light travels in a year. And now we're getting into just gigantic nebulas that contain tons of planets. The pillars of creation, you might have seen pictures of this, it's beautiful. The pillars pillars of creation lie within the Eagle Nebula. The Eagle Nebula is 7,000 light years away from us. Evidence shows that the pillars of creation were destroyed by a supernova about 6,000 years ago. So we only have another millennium to see it. If you don't understand what that means, remember that light takes a year to travel a certain distance. So if something is 7,000 light years away, it means that by the time the light gets to us, that thing is 7,000 years old. The light we're looking at left that original destination 7,000 years ago. So it's kind of a way we can look into the past. Whatever's there may not be there anymore. We only see the light that finally reaches us. And as we get larger and larger, you can see how a light year really isn't that far of a distance. So we're talking just insane amounts of space. The Orion Nebula, large, but really not that large in the scheme of things. One of the most visible nebula ever. As the name suggests, it lies in the constellation Orion. Did you know that bullets of gas exist in this nebula? Okay, here we go. There's the Eagle Nebula. That's where the Pillars of Creation was. I believe they just drew it again in there. The North American Nebula. How sweet. It's named after the continent. This doesn't look quite like a nebula. It's a globular cluster. It is in the Sagittarius Dwarf Galaxy, which would mean it's the first globular cluster outside of the Milky Way to be discovered. Okay, we're getting into some of the bigger nebulas, but guys, nebulas they're just tiny little chunks compared to what they make up, which are the galaxies. Now I see various galaxies here, but I'm gonna hold off until we get to Milky Way. There it is. The Milky Way is Andromeda. Andromeda's gotta be around here too. Well, let's just look at Milky Way. So, all of those stars, all of those nebula, all of those planets make up a galaxy. The Milky Way is the galaxy we live in. You can't see the whole thing at once, of course, but on a dark night you might be able to see a streak that spans the whole sky. It looks milky, so it's the Milky Way. If you live somewhere without light pollution, consider yourself lucky, because if you go outside at night and you see the beauty that is the universe around us, I envy you. I can see just a few little stars up there, like the Big Dipper or whatnot. Even these galaxies, we're at 10 to the 21.7 rather. These are just little galaxies. In galaxies, so you've got the planets which make up the solar systems. The solar systems make up the nebula. The nebula make up the local clusters, the globular clusters. If you get enough of the globular clusters and the nebula together, you end up with a galaxy, but we're talking a ton of them. We're talking hundreds of millions, if not billions, if not trillions of stars per galaxy. And then when you continue to zoom out, you discover that we have local groups of galaxies. Tons of galaxies in a group. It's considered the local group. The local group is the cluster of galaxies that we live in, 95 zetameters. It contains about 80 galaxies and dwarf galaxies. The two largest galaxies are the Andromeda Galaxy and our own, the Milky Way. And then there's the Virgo cluster. It's the largest cluster in the Virgo supercluster, and is at its center. It was discovered in the late 1770s when its galaxies were cataloged as Messier objects. The Virgo supercluster, distance to the Shapley supercluster. Ooh, can't read that very well. So, clusters of galaxies. Distance to the Great Attractor from Earth. What is the Great Attractor? Is pulling thousands of galaxies, including the Milky Way, towards itself. Its mass is tens of thousands of times greater than the Milky Way's. That's crazy. Yottameters. So just some mysterious force of galaxies towards it. A supervoid. Is there nothing in it? It's a region in the night sky that's slightly cooler than the normal CMB temperature, barely above absolute zero. One hypothesis says it leads to a parallel universe. There's a supercluster, sixth largest object known at 1 billion light years. 1 billion light years, more than 1% of the entire size of the universe. And even this right here, this thing, which contains 1 billion light years across worth of stuff, is about 1% of the observable universe. A gigaparsec. It is one of the largest measures of distance. There's really no need to have any measure larger because the radius of the observable universe is only 14 gigaparsecs. So this is a 14th of the universe. The Hercules Corona Borealis Great Wall, largest known structure in the universe. It is made up of galaxies and is called the galactic filament. We are not in it. In fact, it lies about 10 billion light years from us. Distance to the HDF. The Hubble Deep Field is a picture of an empty spot in the night sky. The image had almost 3,000 objects in its distant galaxies. It's unknown whether these galaxies are now, where these galaxies are now, but where they were 12.7 billion years ago is 12.7 billion light years away from us. Like I said, it's like looking into the past, so the light we're getting is 12.7 billion years old. So we're looking into the far distant origins or moments of the universe. Okay, and I would assume that at this point, all the way zoomed out, this is the observable universe. This is everything that we can see, I guess. And we don't know what's beyond that. Light from out here has not made it to us yet. And sure, every year we get to see one more year into the past, but as light travels. But it's inconceivable just how far. Okay, so as we continue, as we reverse our journey, and we decide we want to go home, we're going to enter the Virgo supercluster. We're going to get back into the local group. We are going to find ourselves back in the Milky Way galaxy. We're then going to travel all the way back to, at some point, I forgot to click on parsec. How far is a parsec? Earth's movement around the sun causes nearby stars to appear to move, called parallax. If a nearby star is perpendicular to the solar system and is exactly 1 parsec away, its parallax will be exactly 1 arcsecond. Parallax plus arcsec equals parsec. Okay, I don't know if I understood that. Anyways, we're in the Milky Way galaxy. We are back in our solar system. We're entering past the Kuiper Belt, back into orbit of our original star called Sol, not the sun, but Sol. We are traveling towards Earth. And as we get back to Earth, we find ourselves getting back to wherever we hail from. And as we get closer and closer, we notice landmarks and interesting man-made creations coming into view, all before we realize we are back where we began. Well, that's about all. I really enjoyed exploring this stuff. I wish I understood some of it better, from neutrinos to quarks to superclusters, to parsecs, just all these fascinating terms that help us to understand the universe that we live in. It's really, really fun to explore, and it'd be nice to make more time to explore it. So, thank you so much for joining me. I really do hope all is well with you. I hope you've enjoyed learning with me and just kind of relaxing and chilling. So, thanks so much again, and I will talk to you another time. Cheers.